Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to look at servos and how they respond when they've got low voltage on them. This is a request from one of my Patreons to show how different servos respond with low voltage. So for this experiment I've got my Riden RD6012 power supply. Now this can be connected to my computer using USB, and so I get this nice little power graph showing the current flow, and you can see how it's spiking a lot. You can see I'm actually outputting 3.1 volts, which is pretty steady at the moment, and the blue line on the graph is the current being drawn by the servos. To drive the servos, I'm using the servo tester that I reviewed previously, and I'll put a link in the description for that. And that's being powered by the Riden RD6012 power supply. So I can actually control this power supply from the computer here. So you can see here that the servos are not doing too well, although this big giant servo, which is the HiTEC HS-805BB, that's the dual ball bearing commonly used in the in-move robot, is actually doing a lot better than I would have expected. The little tiny PDI 1109 is actually doing very well as well at that voltage, and this is well below their rated voltage. Don't get me wrong on that. This is a standard MG996R, and from time to time it just hasn't worked at all. You can see at the moment it is working. I should have probably had a white arm on it to make it easier to see. And this one over here that's jumping all over the joint is a I think it's either an SG90 or an MG90, I can't remember. Right, that's an SG90, and you can see how it's jumping all over the place. Now the reason for some of those servos jumping more than others is the smaller ones, for example, are connected through this Y, so the servo cable's a little bit longer. And I probably should connect the bigger ones through a longer length of cable as well, like an extender, just to show how they react at low power. So the problem with voltage drop in wiring is it can actually drop the voltage at the servos down below a threshold at which they do a self reset, and this is the borderline where the current in the servos can actually drop them down, and they will draw significant power on startup and do all sorts of weird and wonderful things, which results in them jumping and carrying on. So while they're stationary, there's a little bit of movement on the HiTEC, but not much. And you can see their power draw has now dropped right down. But as soon as I start to move them, they start playing up. And the reason they start playing up is the current draw through the wire is enough to create issues. So let's just extend our wiring a bit further on these. So this is a extension. Okay, so the output is set to be constant there. The only thing I've changed in this setup is I added this bit of extra wire, and that's causing all sorts of trouble with voltage drop. You can see on the graph it's drawing a lot of power as a result. Now there's a couple of ways you can work around voltage drop. The most common method to overcome a voltage drop issue is to use bigger wires. It is also possible to inject a higher voltage to overcome the voltage drop, but if you've got a variable load on there, like a servo would produce, just upping your voltage is generally not enough. And there's also the risk of over voltage to your servo. So let's just bump this up a bit, and you can see they're just increasing the voltage, overcome the issue quite a lot. So I'll put this back into sweep. Now you can see the little one down here is actually not acting very well. Actually, let me see if I can find another horn for that. Back in a minute. Okay, I couldn't find a white horn to put on there, so I put a bit of tape on. And that lets you see what's going on with it. Now, one of the things I did note was that little servo was actually getting quite warm. So the little PDI 1109 is actually the coolest of the lot, barely showing up on my thermal image map. So I've taken a thermal image photo, and I'll put that in the video as well. But you can see just on that sweep, this is running at 3.52 volt. I haven't got an extension cable on the MG996R, but it is playing up quite a bit. Let's drop the voltage down a little bit further. And make it sweep a bit faster. So 3.12 volts is the threshold for the little SG90. Let's crank the speed up. I'm actually impressed with that little PDI 1109. It's now running at 3 volt. It is through a cable extension, which is going to make it worse. It has a SG90 that's playing up considerably on the same line, and it's still running rock solid. The HS-805BB from HiTEC is working fine in one direction but jumping on its way back. The MG996R is intermittently jumping around and jerking. You can see it actually shaking the whole servo in the process of doing that. But the little SG90, which is a Tower Pro, is absolutely hopeless on the low power. So if you're running quite a significant number of servos off a shared power line of low power, you could be looking for trouble. Now, I haven't actually got a voltmeter showing me what's coming off the servo unit itself, just what I'm feeding to it, but the cable I'm feeding to this is actually a fairly significant cable. Well, that'll do for this little bit of testing. I'm going to crank this up to its preferred 6 volt. And you can see there that they are now all working very nicely. They're all very happy with that voltage. You can also see on the graph what's been going on with the current draw. Now with proper voltage supply, they're all working, they're all running their full path. And look at how much the current draw on the power supply has dropped off. And that voltage draw, or that current draw, I should say, is actually going to make voltage drop issues in your wiring much more of an issue. So I did push these to the extreme of low voltage. Let me just bring it down slowly, so 5 volt. And the current seems to be holding about the same, down to 4 volt. Again, no real significant change in the current draw. Down to 3 volt, and you can see the current spikes, and we start getting, things jump around a bit. Alright, I'm just going to turn off the power supply. And that'll do for this video. This is just a demonstration of how different servos respond at different voltages supply, and you can see how their current spike when you get down too low, and that's the servo controllers actually resetting and then it's driving hard to get to where it's trying to go to, and then resetting as a result of the voltage drop. So I hope this video was helpful and helps explain why we should have slightly larger wires where we're running power. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It tells the YouTube algorithm that you like these videos. It'll help push it to other viewers. It also supports the channel and costs you nothing to do. If you'd like to support the channel further, you can join my Patreons. This little demo was actually a request from Elmorales45, one of my Patreons. You can join my VIP Patreons, Go Lucky and Lorenz Berger, as well as my other two Patreons, Elmorales45 and Ratchet. There's also a Discord channel where you can catch up with me and other patrons and subscribers, and maybe even put forward ideas for videos. And we'll see you in the next video.